Hi, thanks for joining me. Today I'd like to talk about the time varying effect model, or TVEM. TVEM is a flexible way to analyze your data. It builds on the classic framework of linear regression modeling, but it extends it in a way that allows us to address a new set of research questions that has to do with change over time. Like in regression analysis, in TVEM, associations are estimated between predictors and an outcome. However, in regression analysis, those associations between predictors and an outcome are single number summaries. In TVEM, the associations are expressed and estimated as a continuous, non-parametric function of time. Let's take an example. Consider smoking cessation in adults. So we know that when adults quit smoking, their affect or mood is associated with their craving to smoke and with their actual smoking lapse or having a cigarette. Little is known, however, about how that association might emerge or go away with time during a quit attempt. TVEM can answer exactly that question. So let's take a look at an empirical study that answered exactly that question. The data for this study were drawn from a randomized controlled trial, a smoking cessation trial, conducted by our colleagues at the University of Wisconsin. So participants were asked on a mobile device 4 times per day and for 14 days about their mood, their behavior, their craving for nicotine. And so this resulted in up to 56 assessments per individual. TVEM is a very flexible approach, and it can handle unequal spacing and number of assessments within individuals and across individuals. In TVEM, remember that coefficients are not estimated as single number summaries, but they're estimated as coefficient functions across time. We have to look at the results as figures. So let's take a look at a result from this smoking cessation trial. So in TVEM, we have an x-axis that reflects time. In this case, that's the number of days since quit from 0 to 14. And our y-axis expresses odds ratios, or the association between negative affect and lapse in smoking. So at any point in time, we can look up and read off of the figure an odds ratio. In this figure, I've suppressed the confidence intervals for simplicity. However, users of TVEM can request confidence intervals to enable dynamic hypothesis testing that is through continuous time. So first, we found that bad mood or elevated negative affect is significantly associated with smoking lapse. However, that association does vary with time. So we see that in the first week post-quit, that association is small, and in fact, it's not statistically significant. However, in the second week, we see an increasing association such that mood is significantly associated with smoking lapse. We also looked at how craving, nicotine craving, is associated with smoking lapse during the first 2 weeks post-quit. And we see that at the very first day, the association is not significant, but it quickly elevates and remains significant throughout the study, so that craving is indeed associated with smoking lapse. TVEM can be used to analyze many types of data, not just the EMA data that we talked about earlier. For example, we could analyze data from a national longitudinal study to look at substance use as a function of developmental time or age. Let's consider a second empirical study. In this study, we used data from the National Longitudinal Survey of Adolescent to Adult Health, or ADHealth for short. In ADHealth, individuals provided data at up to 4 time points between adolescence and young adulthood. So 4 time points. This is much less intensive than the EMA data we talked about that had up to 56 time points per individual. However, we happen to know the exact age when each participant provided data. Taken together across individuals and assessments, we have very dense coverage of age from 14 to 32. And this kind of information can allow us to answer very nuanced developmental questions using AdHealth data. We examined cigarette smoking from ages 14 to 32. And then we looked at whether biological sex was a moderator of the rate of smoking across age. The first thing we can see is that the curves have a complex shape. They're not linear, they're not quadratic, they're more complex than that. On the x-axis, that's our time axis, we're plotting age from 14 to 32. And on the y-axis, we have the prevalence of cigarette smoking. So the red line shows the prevalence for females across this age range. And we see that females have higher rates of smoking in early adolescence, but very quickly they plateau, and males, on the other hand, start lower than females, but they cross in adolescence, and they peak at around age 19. They go down a little bit, and then they peak again at age 29. And so we see that sex has a time-varying moderation effect. We also examined race ethnicity as a moderator of smoking rates across age. So the red line shows the rate of smoking for white individuals, and the green line shows the rate of smoking for African Americans. And the first thing we see is that the rate for whites is significantly higher than the rate for African Americans across the entire age range. We also see that the blue line, Hispanic individuals, start out with rates very similar to those of whites, but they're very flat across age, and they land at rates very close to those of African Americans. One interesting aspect of this study is that attributes that are fixed, like biological sex or race ethnicity, can have associations with variables that vary over time. In other words, time-invariant covariates can have time-varying effects. So in summary, TVEM does not replace any of the methods that we all use today. It adds a new dimension to our analysis, the dimension of time. It opens up new research questions that can be answered for years to come. The citations for the studies that I made reference to today will be provided at the end of this video, and thank you so much for joining me. So the data for this study came from a smoking cessation randomized trial that was conducted by our colleagues at the University of Washington. Washington, Wisconsin, whatever.